While these changes were being made, the parts and pieces needed to assemble the giant Saturn V moon rocket came together at the Kennedy Space Center, Florida. Everything associated with the Saturn V was huge. The rocket itself, the building where it was assembled, and the crawler transporter that carried it to the launch pad. The fully loaded Apollo Saturn V was 363 feet tall. Its main engines alone generated 160 million horsepower, and its fuel pumps pushed fuel to the engines with the force of 30 diesel locomotives. As Saturn V lifted off Launch Complex 39 for the first time, it weighed more than 2,800 tons. Pace quickened. Starting with Apollo 8, every Saturn V launched had a three-man crew. Two days before Christmas in 1968, astronauts Borman, Lovell, and Anders became the first humans to pass out of Earth's gravitational control and into that of another body in the solar system, the moon. The hardware to travel to the moon had worked well, and landing sites looked good. Our Earth seemed small and fragile, hanging in the vastness of space. This view of ourselves from lunar distance would change the way we think about Earth for all time. It raised profound questions, especially those associated with the Earth's finiteness and unlimited resources. The next two flights, Apollos 9 and 10, would continue dress rehearsals for the first lunar landing. All systems were indeed ready. Astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins would make the historic journey. Next stop, Tranquility Base.
2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Houston, Apollo 11 is calling you in the high gain. How do you read, over?
Roger, loud and clear on the high gain.
Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase. Everything looking good. Altitude 42.
You're go for landing, over. 40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 9.5. 30 seconds forward. Contact light. Tranquility Base here. The Eagle has landed. That's 1 small step for man, 1 giant leap for mankind.
across the country and around the world, the Apollo 11 crew were welcomed back as heroes. Meanwhile, more than 100 scientists from here and abroad began intensive studies of the lunar samples. Before Project Apollo ended, 6 additional flights to the moon were made, and all but one were highly successful. Skylab was the next manned spaceflight. Launched first was a 2-story orbital workshop. Then the first of 3 three-man crews departed to meet, join, and begin living in the orbiting laboratory. Those crews would stay 28, 59, and 84 days respectively. One of the major objectives was to find out if astronauts could physically withstand extended stays in space and continue to do useful work there. The answer was a resounding yes. Experiments in astronomy, Earth resources observations, materials processing, and crystal growth all proved highly successful. Then ASTP, Apollo-Soyuz Test Project, a joint endeavor between the Soviet Union and the United States. The mission called for a mutual docking and crew exchange to develop the necessary equipment for international space rescues. Before, during, and after Apollo, Skylab, and ASTP, NASA's unmanned planetary programs were giving scientists exciting new glimpses into the history of the solar system, from early explorers to the infrared astronomy satellite. 7 Mariner spacecraft flew by the planets Mars, Venus, and Mercury, sending back a stream of pictures and data. 10 Pioneer spacecraft did likewise, including Jupiter flybys and probes through the atmosphere of Venus. Pioneer 10 became the first man-made object to leave the solar system. Atmosphere physics, astronomy, meteorology, and geodesy. These are just a few of the scientific disciplines studied by dozens of Explorer-class orbiters through the years. Hundreds of sounding rockets have probed the atmosphere above where balloons are effective, but below the area that satellites fly. Biosatellite was sent aloft to answer basic biological questions. Will cells divide normally while weightless? How does zero-G affect plant growth? Would radiation and weightlessness be a hazard on long-duration space flights? Everything from plants to primates were orbited aboard Biosatellite to find out. There were the OGOs, orbiting geophysical observatories that blossomed out like giant dragonflies in space. OSO, orbiting solar observatories, studied our sun and its influence on Earth. In the last 25 years, our orbiting astronomical observatories have radically changed our view of the universe. We now see a dynamic universe of quasars and black holes and other extraordinary objects, of cataclysmic forces causing the birth and death of stars, of billions of galaxies wheeling in the immensity of space. We looked back at planet Earth with Landsat remote sensing satellites. Crops, forests, pollution, all can be photographed in great detail to help us better manage our Earth's resources. The Viking program was a systematic effort to investigate the planet Mars. 2 separately launched Viking spacecraft, made up of a pair of orbiters that would photograph from above the planet, and twin landers built to descend to the Martian surface, spent 11 months and 420 million miles traveling to the mysterious red planet. The lander's robot arm conducted chemical and biological tests on the soil in a search for life forms. Martian weather and seismic reports were also sent back routinely. Cameras began returning pictures, thousands of pictures. Color photographs showed a surface littered with rocks. A fine dust, red or yellow-brown, could be seen everywhere. We even had a chance to view the 2 moons of Mars, Phobos and Deimos. Viking's complex science and technology were considered to be a triumph equal to the landings on the moon. Two unmanned Voyager spacecraft carried a record with the sights and sounds of Earth, just in case they encounter a cosmic neighbor along the way. Their interplanetary journey was designed to take them past Jupiter and Saturn, and eventually one Voyager was to pass close to Uranus and Neptune. Voyager sensors recorded Jupiter's intricate weather patterns and detected massive lightning bolts in its churning cloud tops. It took 40 minutes for a signal from Voyager passing Jupiter to be received by mission controllers at the Jet Propulsion Laboratory, so the spacecraft had to be essentially automatic. Voyager also took a good look at Jupiter's largest moons. There's Io with its active volcanoes. Europa. Ganymede, the largest moon, appears